Hey folks, Quilly here, and it's only now that I just realized that my little outline had the wrong number because of me going and making some changes somewhere along the way. So we had two step twos. It's fine. Hey, it's the next episode of our Godot learning series where we are trying to reproduce the classic game Asteroids here in Godot and learn about the changes, especially for people who are coming from Unity. Last episode, we left things off. We've got our asteroids and our ships moving around using the physics system, which is groovy. But the problem is, in classic Asteroid, when you go off the edge of the screen, you're supposed to wrap around to the other side. So we're going to go ahead and work on that. Now, before we actually do the wraparound code, we should talk about some aspect of our game that is the shape of the window we're in, right? If our game involves wrapping around the edges of the map, that means that visually speaking, the screen we've got here is the play area. And the game will feel very different if our play area is huge and we've got lots of room to navigate around our asteroids, or if the play area is super tiny and everything is really crowded. We've got people who are going to be playing at different resolutions, right? Full screen, wide screens, anything like that. If we port this to phones, then we're going to have phones with slightly different sizes for their screen. And if you do play in a window, then you can have different window sizes. We could stop the window from being allowed to be resized, but that won't be a good solution to people who are playing on, monitors with different resolutions. We want the game to play exactly the same regardless of what resolution we're on. And for that, we're going to have to do a little bit of logic around the viewport. So if we go into project and project settings, and we scroll up to the top here, under display and window, we've got this viewport width and height setting. Now, this actually coincides to a couple of things. First of all, in the editor, I'm trying to zoom out. Apparently, I do have to close this before I get back to the editor. In the editor, you can see this little sort of like purplish line here. This is the size of the viewport that it's previewing. And that is also the size of the window that is opening up. I mean, it doesn't match here because I'm not at 100% zoom, but that is this viewport over here. We can change these numbers. Let's say, okay, well, Asteroids is an old classic game. These old classic games tended to run in a 4:3 resolution ratio. So let's set our viewport to 800 by 600 pixels, right? So we've got that kind of old schooly kind of vibe on it. And if we go ahead and hit play, and also if we look at the preview square over here, we indeed have sort of a square kind of view, kind of old school monitor shape. Great stuff, but we can still, again, resize this. And again, I could just turn off the ability to resize it, but that's not the good solution. What we want, and it's also worth noting that your viewport width and height over here, if you go to advanced settings, you can independently change the window height and width independent of the viewport stuff if you'd like. But that's not what we're looking at today. What we're looking at today instead is enabling the stretch mode. What this will do is this will make it so that the viewport, the canvas that your game is actually being played on and rendered to, will always be the same size in terms of your internal game logic, but it will be stretched to match the size of the window or the monitor of your end user. So we are going to go from mode, we're going to switch from disabled, and we're going to pick one of these two. These two effectively work the same way in terms of your mechanics. The difference is the viewport mode. As you can see right at the very bottom of this tooltip, the viewport mode is what you want if you're doing pixely kind of graphics, because it keeps those like sharp, blocky edges, whereas the canvas items mode is what you want if you've got graphics that are sort of just like non-pixely and more smooth, which is what our graphics are. So we're going to go canvas mode. Mechanically, they're going to do the same thing, just a slightly different look. You can also change a few options in the aspect, but keep is what we're looking for here. So if I close this and hit play, everything looks the same here, right? But now, if I go and stretch this window open, you can see now the graphics all scale up, which means no matter what the size of this window is, the logic, the mechanics of the game are going to be identical. The play area, the arena that our player is in, is going to be the same, because while the arena gets bigger, so do the players, so the ratios stay exactly the same. The other thing this does for us is it deals with different resolutions. If someone's loading this full screen on a super widescreen monitor, well, they'll still have the same play area. And then, I don't know, do anyone use like vertical orientation monitors? I do for code usually, but there you go, same thing. So we've got a play area that is consistent. Now, for some games, this isn't going to matter, but for our game, that's going to be critical, because our game logic is going to be very much tied to the play area. Now, keep in mind, our play area could even be smaller if we decide to have like borders and things like that for user interface things, but this will be good enough for now, so we'll do that. Okay, so we've implemented this viewport that's got a fixed size, so now we can think about how we get our objects to loop when they go off the edge of the screen. So for that, let's go back to the one script we've been working on, which is our player script. And what we want to do is we want to put in some sort of check. Let's make a little function here. This is going to be called viewport wrap. Wrap to viewport. Wrap to viewport. And let's think of what we're doing here. If we are off the left side of the screen, set position to right side of the screen, right? That kind of makes sense. And obviously we'll have to do the other directions first, but let's consider this one side first. And also let's remember that we've got to put in a colon there. And we'll also get an error because right now there's no instructions this, but we can put a little pass and that should get rid of all the error messages. Oh, complaining about the tabs there. There we go. There we go. Okay. So we're going to have some sort of wrap to viewport function that works this way. Now, how are we going to handle this? Well, I guess, it'd be something like if position dot x is, let's say, less than 0, right? Then we want to set position dot x to be the right-hand side of the screen, which you and I know is 18 because we just set it there. But I mean, we might change our mind on that. And here's sorry, I said 18. 800. And this is going to be true. Again, the viewport is not the screen size. You can get the screen size, but the viewport size is always going to be 800 because of what you said there for the width, and it's going to be 600 pixels high. But we don't want to hard code this in. This seems like a terrible idea. We want to get this on the go. So how do we get this information? Well, we do have access to a couple of different things. We can get viewport rect dot size dot x. So if we did this, if we go off the left-hand side of the screen, it's going to go ahead and wrap us to the right-hand side of the screen. So let's try to call this wrap to viewport function inside of our physics process. Again, spoiler alert, this is not the way we want to do things, but let's give this a try and see what happens. And hit play. I'm going to try to move off the left-hand side of the screen. Okay, well, something happened, although I'm now stuck for some reason. It's because we broke physics. Again, we did a teleportation in the middle of the physics processing, right? Physics process is being called every frame for every single object. And somewhere along the way, while all these objects are being crunched, one of these objects magically teleported. This is a terrible, terrible, awful, not good thing to do when you're working with the physics system. Because again, we've just bent space and time in a way that's inappropriate. So instead, if you're going to make changes to something like the position, you want to do it in between the full physics process. And that's where integrate forces comes in. This is a function that gets called after all the physics processing has been done. And what it does is it gives you a final opportunity to manipulate in a way that is actually safe the state of the world. And you do that not by directly writing to your position or anything like that, but instead inside of state, you've got a copy of what the future state of your object will be. Now, there is a slight caveat here that's a little bit of a gotcha. We've been using position.x to make changes to our position, which makes sense, but position.x is actually just kind of a convenient shortcut. Position.x is the exact same thing as transform.origin.x. This is the exact same as position. And the reason I'm doing this, oh, it's complaining about the lack of a little pass here. The reason I'm doing this is because inside of state, there is no state.position. Instead, there is only state.transform.origin. So what we want to do is we want to make these checks based on the version of transform in the state rather than the object itself. So we're just going to make a slight change here to wrap viewport. We're going to accept the state, and we're going to check if state.transform.origin is less than x, in which case state.transform.origin.x is being set to a new value. So I'm going to also remove the call to wrap to viewport from inside a physics process. And now if I run this, we should be able to move off the left-hand side of the stage without breaking the universe. Oh. Forgot to call the function. Because I knew there was a line in integrate forces. I didn't realize it was the wrong line. Let's try that again. Go off to the left-hand side. Hey! Beautiful. So that is working the way that we want over that way without shattering the universe. Cool. Let's do the same thing over on the right-hand side. So if we want to be able to go off the right-hand side of the edge, right? We're going to say if the .x is greater than the get viewport rect .size.x, right? And then we're setting it to 0. And right away, you're going to say, okay, well, there seems to be an inefficiency here. First, let's just make sure it works. Now, can I go off the right-hand side? And it works properly, and we can still go off the left. Cool. But we don't, because this Raptor viewport is running every single frame. So every single frame, we're going to do multiple calls to get a copy of the viewport rectangle and then get its size parameter. This seems like something we should probably just cache. So that's what we're going to go ahead and do. We're going to create a variable called viewport size. And it feels like it should make sense that we can, oh, I didn't realize I can zoom in this editor. That's quite good, because I know people want larger fonts, although it's a little bit crowded in here. Okay, I've been big in the font a little bit. Hopefully it'll make it easier for people to read on screen. Inside of our ready function, which gets called one time for the node, we can go and say that our viewport size is equal to, go way autocomplete, to this. There you go. And then I can replace these extra calls to just this, viewport size.x and that. So if we run this, again, we should be in a state where we're working just fine. And we are. Here's one of the interesting things, though, in Godot. We don't actually need this ready function most of the time. When we're just doing things like this, what we can do instead is when we're going and defining our little variable, I can say on ready, do this. And that's the equivalent of doing something inside of the ready function. And it can keep our code a little bit just sort of neater and cleaner, because then you're defining your property and setting it at the exact same time, and it feels kind of good. So we've got that, which is great. There's still something that's a little bit less than ideal here. And this is much more obvious when we're moving at low speeds. If we slowly go in low speeds, you'll see when the midpoint of our ship passes the border, we're going to instant teleport over there in a way that's kind of visually unappealing. Now, if we were really simulating the old school asteroid, the second part of our ship was over, we'd have part of it show up over here too. Now, that's actually relatively easy to do if you're doing low-level drawing routines like the OG asteroids was, because you just your pixel drawing code, you just put a little like modulo in there to wrap based on the width of the screen. And that would be pretty easy to do. But because we're working in sort of a higher level abstraction of our visuals, that's not really an option. You might be able to do something like that visually with like some shader code or something, but that wouldn't handle like the collisions, right? Because if part of your ship is hanging over here, then it should be possible for you to be hit on this edge of the screen as well. The fix for it really would be here to have 2 copies of your ship at any given time. So as you're moving off the left-hand side over here, the second copy of your ship would become visible over on the right-hand side ahead of time and would be a valid target for collision. And if either one of the clones of your ship is hit, then that would count as being hit for the purpose of, you dying or something like that. We're not going to bother with it in this particular example. Instead, what we're going to do is we're going to wait until our ship is off the edge of the screen completely before wrapping around. So for that, we're going to need to know the size of our sprite. And so what we're going to do is we're going to do another little on ready var sprite size. And we're going to decide the size of our sprite. Now, there's a couple of different ways to do this because we do have access to the ability, we can get a node by name, we can get child. There's a bunch of different ways that we can get nodes by writing some code. But because we're working in GDScript here, there's a very convenient little shortcut. We do $sign and then write the name of the child. In this case, the child is literally just called sprite2d. This is not the class, right? If the player's sprite here, if I was calling this like graphics, right? Then this would be $graphics. Again, I'm not writing the type of the node, I'm writing the name of the node. So I could do this dot getRect dot size. Very, very similar to this. Also, I should actually note, get viewport rect is actually specific to node 2D. I think we can also just do get viewport and then not size. I think that comes out to the exact same thing. Let me just hit play and confirm that. Again, we don't have the off the edge. Yeah, see, that's working perfectly fine. So to me, this is better because actually you can do this line inside of something that's not descended from node 2D, whereas get viewport rect is only in node 2D. I don't know why it's like that, but it is like that. So you know what? I'll make a change over there. So we got a viewport size, we got sprite size. So we're going to make a slight change over here to our code where if our origin x minus our sprite size dot x divided by 2, then we want to loop to the other side, but we want to go off the screen that way. So now if I do this, it shouldn't loop us until the visual of our ship is completely off. Whoop. Yep, inverted this. This needs to be a plus. That still needs to be a plus there. Now, until it's completely off, I think this code is causing us issues. Yeah. Because then what it's doing is spawning us off screen. Perfect. And so now we need to make a change over here so that it's not trying to loop us as soon as we're off screen, because that's what was causing the weird like copy here. We just want to say the same sort of thing, minus is greater than. Yep. And then we want to set ourselves to negative over there. So that should be correct. And we're going to duplicate all this. Let me get rid of its pass command. Doesn't have to be here anymore. Boom. And so we want to do the same thing in the Y direction. I'm hitting X instead of Y. Like, why isn't this working? Might have been able to do a find and replace on this block, but I wasn't 100% convinced that I wouldn't accidentally do something else. So now we should be able to loop around in any direction. There we go. And we don't get the visual artifact of teleporting. It is a little unfortunate. It waits until we're off screen. It's not an exact clone of asteroids, but it's going to be good enough. Now, I think... yeah, we have this. I guess I'm going to do this now. This video is going to be a little bit longer. We're going to refactor with shared base class. What am I talking about with this? Well, the thing is, not only my ship should loop around, but my asteroids should loop around as well, right? And currently they're not doing that. So what I could do is I could take all this code, copy, I could go into our asteroid, right? My asteroid over here. Let me create a script on this called, I'm just going to call it asteroid. And in here, I could do, a bunch of pasting and duplicate the code and all those things. Anytime you find yourself duplicating the code, things are obviously quite bad. Because what if I realize that, you know what, I want to make the wrap to viewport work slightly differently. What if I hadn't done the sprite size part of the code first, right? And I'd written all this, copied over the asteroid, and then realized I wanted this wrap code, and now I have to make the changes in both places, which is terrible. So in practice, what I think we want to do is we want to have both player and asteroid. Either we want to make wrap to viewport a sort of a generic global function that I can call anywhere, or, and what I'm going to do here is I'm going to have asteroid and player both extend the same base class. We're going to make a new class called rigid body 2D wrap. So over in my file system, I'm going to create a new script. It's going to be called rigid body 2D wrap, and it's going to descend from rigid. Well, actually, I could just type it in myself, but and like the code, but I'm going to do that. We're going to start with an empty file, and that's going to be fine. So create. So I have an empty file that extends rigid body. So rigid body 2D wraps extends rigid body. And what I can do right away is I can tell, listen, player, you're going to extend rigid body 2D wrap, and so is asteroid. Done, done. We're getting error. Why is that? Can't find a class called rigid body 2D. I told you previously that while we are writing a class over here, by default, these classes don't have a name. We have to explicitly specify that this class is not anonymous, but has a name. It is called rigid body 2D. So now, go over here. These errors should go away. There we go. Beautiful. Because now they know of a class name. That currently doesn't do anything. What is this class going to do? Well, this class is going to clone this stuff here, the integrate forces, and then a call to wrap to viewport. It needs copies of sprite and viewport. So over here, same thing. We're going to go and cut that out. And I guess we'll leave the class name declaration up top. That sounds fine. And we'll put those over there. Now, we are going to have to be consistent. We're going to have to make sure that our sprites always have the same name everywhere. So either we're going to have to choose graphics or sprite 2D or something else. I'm going to suggest, I'm going to standardize on sprite 2D. And so that's what we'll just search for. Search for a child named sprite 2D, and that's going to be basis. So our player here has got this. This asteroid has got this. I'm going to get rid of these other two asteroids because I didn't assign a script to them. Clearly, we're going to have to do prefab stuff. So hang tight for that. But now, the player, we don't have any of the wrapping code in the player, right? If I hit play, our player should still be able to wrap on each side of the screen. And in fact, if I go and shove this asteroid hard enough to get it moving, it should show up over here. There you go. So they have the same base class, so they have the same behavior. Beautiful. All right, I'm very happy with that. That brings us to the end of that particular note. So next episode, well, I mean, obviously collisions are happening because they're all physics-enabled objects with colliders, but we want to respond to the hit signal. We want to have the player recognize that it has been touched, and we're going to deal with that. And then maybe deal with some Area 2D refactor as well. We'll take a look. Thanks for watching, folks. I'll see you next time. Bye-bye.